Hello. In this problem, we have been given a scenario and a function with a graph. We are told that the position y of a car driving along a straight road at time t in minutes is given by the graph. The car's position function has units measured in thousands of feet. For instance, the 0.24 on the graph indicates that after 2 minutes, the car has traveled 4,000 feet. What is the average speed of the car over the first 4 minutes of the drive? I've annotated the problem a little to remind us what we're really looking for, and here I'm going to really highlight that question. Let's go through the steps for how to find the answer to our problem. So in this case, because we're working from a graph, we're going to want to build an input or output table to help us out as one way to keep track of what we're looking at. So I'm going to have my inputs. They're measured in t, and they're measured in minutes, versus my outputs, which are y's, and they're measured in thousands of feet. So this is representing how this car drives. Think for yourself for a second. What does it mean over these intervals? Do you see like the interval from 2 to 2.5? We have this period where the distance, the position is flat. That's a sign that the car must have paused for a moment. It wasn't moving then because the position didn't change even though time went forward. Maybe they're braking. All right. We are told we're going over the first 4 minutes. So as I've built my table, now I'm going to need to identify the points I really need for my table. So first 4 minutes tells me I'm starting at time 0, and I'm going to end at time 4. So now I'm going to read off the graph the y's associated to these x's. So at time 0, I'm right at the origin. And if I'm at the origin, my y coordinate is also 0. And actually, I'm going to code the end a different color so that we can see it. At the end, we were at time 4. So I'm going to read along my graph. If this marker along the bottom of my graph is 2, then 4 should be halfway between 2 and 6. That must be where 4 is. So this is t equals 4. So I'm going to read across, and I get that the y is 6. So that's my input and my output. So now I can identify those as points 1 and 2. The first part will be my point 1. Let's write it as an ordered pair, 0, 0. And the second point will be my point 2, which we can write as an ordered pair, 4, 6. x1, y1, x2, y2. You don't have to label the x's and y's if you feel comfortable with this. We have now made it through the first 2 steps. We are on to step 3, build a fraction. So I'm going to build a fraction. There's my fraction bar. Step 4. In step 4, on the top, I'm going to subtract y2 minus y1. y2 was my ending y, 6, minus my starting y, which would be 0. That's my change in y. This is my rise. If we look on the graph, we can see the rise as being the vertical change. There's my rise. All right, next we're going to do our denominator. We're going to find our run because we have finished step 4. On the bottom, subtract x2 minus x1. This is change in x or run. So our ending x was 4 and our starting x was 0. And that's our run. So the run, if I go back and look at my graph, it's the length of that distance, the change in the x's. Now notice the graph shows me it's not going to make that line that we usually see. The graph doesn't have a straight line appearance, but we still have a rise and a run we can talk about. We just know that it's averaging out. It's not telling it exactly. So we've done that step. Okay, think, what are the y's measured in? We have our y units. We want to write that next to the rise. Okay, so here's our rise. Our y units were measured. I'm just going to write it on a fresh line here. Our y units are measured in, look back at my table, thousands of feet. Or if you wanted to, you could actually just write it out as 6,000 feet. And then we have our run units. Run was measured in, what were those? Oh, if I look at my table or the information in the problem, that was measured time t in minutes. So what do we get here? We get that now that we've done steps 6 and 7, the average rate of change, and I'm going to just write ROC for rate of change, will equal my 6,000 feet divided by my 4 minutes, reducing that fraction. 6,000 divided by 4 is 1,500 feet per minute. And I can either write the word feet or I could also write it as this, feet over minutes. Those are two equivalent ways of writing that.